For today, let's look at this interesting number theory question. Let n be a positive integer with exactly 4 factors, including 1 and n. If n plus 1 is equals to 4 times the sum of the other 2 factors, you're asked to find the largest possible value of n. Please have a good try before you look at the answer. Using this condition, n is either equal to p power 3 or n equals to pq for some distinct prime p and q. Let's consider case 1, where n equals to p power 3. In this case, the 4 factors of n are 1, p, p squared, and p power 3. Using this condition, we know that n plus 1 equals 4 times p plus p squared. Since n equals to p power 3, p cubed plus 1 equals to 4 times p plus 1. Note that we can factorize p power 3 plus 1 as p plus 1, p squared minus p plus 1. And since p is positive, p plus 1 is not 0, we can cancel this common term, and we have p squared minus p plus 1 equals 4p. This is actually a quadratic equation, that is p squared minus 4p plus 1 equals 0. From Vieta's formula, the product of roots is c over a. In this case is 1. And since the product of roots is 1, these roots are not prime numbers. This means that case 1 cannot produce any good answer. Now we should consider case 2, where n equals to pq. Again, in this case, the 4 factors are 1, p, q, p times q. From the condition, n plus 1 equals 4 times p plus q. n itself equals pq, so we have pq plus 1 equals 4 times p plus q. So pq minus 4 times p plus q plus 1 equals 0. We can add both sides by 15. 1 plus 15 is 16. And from the left hand side, we can factorize this expression as p minus 4 times q minus 4. For 15, it can be written as 1 times 15 or 3 times 5. Without loss of generality, we will let p less than q. From this expression, p minus 4 times q minus 4 equals to 1 times 15 or 3 times 5, we obtain pq is either 519 or 79. We have to reject the second answer because 9 is not a prime number. This means that we have a unique solution for pq, that is 519. And since n equals pq, it is 5 times 19, which is 95. So we'll gather all the information for case 1 and case 2 here. In conclusion, the answer for this question is 95. That's all for today's lesson. I'll see you again next time. Bye bye.